Okay, so today we continue on with lesson 5.4. Actually, this is part 3. So I want you to take a look at the problem of the day, pause the video and solve it, square and correct the error in factoring completely. So today what we're going to take a look at is it's like I said, well, if you look at the top here, it's called a factor review. We did 4 new types of factoring in 5.4. 2 types that you've already sort of seen in part 1. In part 2, we did 2 new types. Now this is actually part 3 where we're going to mix them all together and sort of take a look at, well, if I give you all the problems mixed up, how do I know when to use what method? Now me personally, I like to sort of start at the 4 terms because I think that's actually the easiest one to spot because it's the newest one we learned in the last part of the lesson. So if you have 4 terms, you're going to solve by grouping. And if you take a look, I only have one set of 4 terms here. It's this one. I need to write this down. I'm going to just slide it down in the notes here. And we're actually going to solve it. So each of these problems up top are going to fit into one of the categories. There's 5 spots here. I'll solve them as I go. Now always ask yourself, is there a GCF to start off with? I didn't actually ask you it with this one. You always want to see, is there something they all have in common? Obviously here they don't. So we're going to do with 4 terms, which is grouping. Grouping means I factor something in common out of the first 2. I get what? X to the 4th. I'm left with x squared minus 4. Close parentheses. And then in the next group, I'm going to factor out a negative 9. Now grouping states that in the first parenthesis, I put the coefficients, so x to the 4th minus 9. And then what repeats is written once in another parenthesis, x squared minus 4. Now, normally that would be your answer, but first we have to ask, is there a GCF they have in common? Then we factor. Then we also have to ask ourselves, can we split them up further? You can actually split them both up. The first one is going to be x squared plus 3, right, because 9 is a perfect square. X squared minus 3. You can actually split up the other one. It's a difference of 2 squares. X plus 2, x minus 2. That's actually your answer. So now, like you see, we're pretty much combining everything together. We'll go in order for the next one. 3 terms. We're just going to use factoring like we learned with quadratics in the last chapter, and what you learned in Algebra 1. The one that has 3 terms is this one. Move it over here a little more so you can see it. So with this factoring, you see that once again we address the GCF. All 3 terms have nothing in common, so we can't actually do that. So go straight to factoring. Now be careful, this is one of the guess and check ones because we have a 2 in front of x to the 6th. So 2x to the 3rd goes to 1. And x to the 3rd goes in the other. Signs are the same, they're both positive. Now we have to figure out our factors of 6. What do I have? I have 3 times 2 and 6 times 1. Placing it correctly to get a 13 here. Try it yourself. You should get 6 times 1, which is 6, and we want to set it up here. Do your check OI. What's our outer? Watch what I'm doing here. 2x squared times 6 is 12x squared, plus inner 1x squared. Make sure that looks like a 2, because it doesn't look too well there. If I ask myself, can I factor further? The answer is no. There's no perfect squares. And when it's 2 terms, you usually need that minus sign to be able to do that. So that's my final answer. 2x squared plus 1. Oh, actually, hold on. Let me fix that. I wrote it wrong. That 3 was correct. My 3 didn't look too great before, so see if I could erase it here. Make sure you have a 3. That's my fault here. We know why it's a 3, right? Since I rewrote the one wrong, I'll try to fix it. 6 is what? 3 and 3. We split 3 x's here and 3 in the other. So be careful. Make sure that's correct here. Now that I fixed it. So it's an x cubed for both of them. All right. So now we have 3 types of 2 terms. I'm still working from right to left. First one I'm going to want to look at is what we learned in the last lesson in part 2, which is the sum or difference of 2 cubes. I think that one's sort of easy to see because there's 2 terms and then you see a third power somewhere. So this one's the sum, this one's the difference. How we set this up, if you remember, is quantity cubed plus quantity cubed. What cubed gives me 8x squared is 2x. And then this will be what, 3? So A is 2x. B is 3. And then that formula you have to remember, you have to plug them in. So it's 2x plus 3 then it's a squared. Be careful, a squared is the whole quantity, so it's 4x squared minus a times b, or 6x, plus b squared, which is 9. And that's my answer. So take a second. I want you to try the difference pattern. I mean, obviously it's the same numbers, just the placement of the sign is different. But I want you to try the difference of 2 cubes first, then I will show you the work to it. Now hopefully it's okay with you. I didn't show the parentheses cubed or the A and B. They're obviously the same A and B. The sign placement is different. The minus is here, goes minus plus plus as opposed to plus minus plus. Okay, so we're getting there. Let's see what's left. We're getting to the end. The next pattern we want to take a look at is difference of 2 squares. It's not always necessarily a square. Could be a 4th power, whatnot, but let's see. 4 and 9 fit. So the ones that fit under difference of 2 squares, obviously this is the square one. 4 and 9 are perfect squares, and it's a difference, the minus. But take a look, this one is also going to fit as well, because 16 and 25 are perfect squares with a difference, and x to the 4th is an even power. So this one's a difference of 2 squares. This one would be what? A difference of 2 4th powers, I guess you would say. Anyway, that would mean 2x plus 3, and then 2x minus 3. And that would be your answer. Same idea with this one, but be careful, it's an x to the 4th and not x squared. So we're going to put a 4x squared in each parenthesis. And then plus 5 minus 5. And I write a little bit big, so I'm going to write the other part here, 4x squared. That would be our answer, side by side, obviously. All right, so we have one last one left, one last type. What if you could just do the GCF? This is 2 terms. They only have what in common? They only have a 9, right? Do you guys see that? So factor out a 9. I'm left with x squared plus 4. Now think to yourself for a second. Can I factor further? What do I have? X squared plus 4. Hopefully you realize it's a no. Yeah, it looks like the difference of two squares, but the key thing is it's not a difference, it's a sum. The only sum pattern that we have is for when it's a cube. So to finish off the lesson here today, always look for a GCF first, then figure out what kind of pattern you have to factor, then always ask yourself, can you factor further? All right, and it's up to you. You might want to do all the four terms with grouping first. You might want to go through the problems and do all of one type first, or maybe you want to go one problem at a time and look it up from the chart. So your homework for today is the problem of the day. Then I want you to complete these three problems on assignment 9, and then in class we will finish the rest of assignment 9.